Hey guys, it's Miss Ava here, and I'm here with my student Calculina. And in this video, we are going to look at divisibility rules for numbers from 2 to 10, and then I have a few extra ones in there for you guys too. These divisibility rules are awesome because they can help you do math much faster and just feel more comfortable with numbers. You don't have to keep reaching for your calculator all the time. Before we get started, make sure to download the PDF with extra practice problems for you to try and follow along. So let's go ahead and get started. Okay, so these are divisibility rules, which means that they are just telling you for the numbers from 2 to 10, how to tell if something is divisible by each of these numbers. So the first one we're looking at is how to tell if a number is divisible by 2. This one's kind of easy, kind of obvious. What do you think the answer is, Calculina? How can you tell if something's divisible by 2?
Um, it's an even number?
Yes, exactly. It is an even number. That's how you can tell. So that means that it ends in 0, 2, 4, 6, or 8. So any number that ends with those is going to be divisible by 2. Next rule is how to tell if you have a number that is divisible by 3. And we have some numbers here that we can try, but I'm going to tell you what the trick is first. The trick is that you have to add up all the digits, and if the sum of those digits is divisible by 3, then that means your original number is also divisible by 3. That's the rule right there. You have to get the sum of the digits and then see if it's divisible by 3. So let's try it out with this first number. You're going to add these guys. What do you get? What's 4 plus 6?
10.
Okay, and then plus another 8.
That's 18.
Okay, good. And then another 3.
21.
Good. And then plus 2 and then plus 1.
That is 24.
Awesome. So you end up getting a 24 when you add up all these digits. And is 24, is that divisible by 3?
Yes.
Okay, good. So that means that this number right here is going to be divisible by 3 as well. So that's basically how that works. Let's try these other two. Just the 46. Is 46 going to be divisible by 3?
No.
Okay, how do you know?
Because, 10, 3 doesn't go into 10 evenly.
Yes, exactly. So you added these two and you got a 10, and then we know that 3 does not go into 10, so 46 is not going to be divisible by 3. Another thing I want to point out is, like, let's say you added these and then you got some number and it was still really big and you couldn't tell if that was going to be divisible by 3, then guess what? You can just add the numbers again. So if you add 2 plus 4 here, then you get 6, and then you can see if 6 is divisible by 3, and it is. So that's another, like, you can do it twice to be able to tell for the original number. Okay, and then the last example here is 101D1. Just kidding, 111. Is that going to be divisible by 3?
Yes.
It is good, yes, because you added the 1 plus 1 plus 1.
Yeah.
Okay, good, yes. You add those guys, you get 3, and then we know 3 is divisible by 3. The next rule is actually really similar. So a lot of these rules, they kind of they come in pairs, and 3 is one of them. So this one is paired with 9 because 9 has the exact same rule, except this time you divide by 9. So if the sum is divisible by 9, then that means that your number is divisible by 9. So this is the example we just did, and we added all of those numbers, and what did we get for that, Calculina?
Um, that one, wasn't it 24?
Yes, it was 24. And so now we do the check. Is this going to be divisible by 9?
No.
Exactly. So that means that even though this is divisible by 3, it is not divisible by 9. So this is a no. And then how about this one? It's the exact same number except the 4 at the end. So it's not a 1. So then that means what is the sum going to be?
So it's just like 3 more than 24. Yeah?
Yes, it is exactly.
Okay, so then that would just be 27.
Perfect. And is 27 divisible by 9?
Yes.
Exactly. So then that means that this one is indeed divisible by 9. So that way you can just tell from looking at a number or just counting it, doing the sum in your head, if it is divisible by 9. All right, next rule. This one's kind of an easy one as well. To tell if a number is divisible by 5, basically the only thing you have to look at is if it ends in 5 or 0. So it has to end in a 5 or a 0. And so let me do that in the rules so you can see it right here as well. So let's do for all of these guys. So 295, that one ends in 5, so it is going to be divisible by 5. 290, that one ends in a 0. And so, yes, it is also going to be divisible by 5. But 292 does not end in a 0 or a 5, so this one's going to be a no. So that one's kind of a pretty easy and obvious rule, just like with the even numbers over here. And this is also another one that comes in a pair. So that's the one we're going to look at now. How to tell if a number is divisible by 10. So a number is divisible by 10 if it ends in a 0. So that's the rule right there, ends in 0. And so this one, although it was divisible by 5, is not going to be divisible by 10. And this one will be divisible by 10 because it ends in a 0. So that one's also pretty simple and straightforward. All right, next rule is how to tell if you have a number that is divisible by 4. So to tell if a number is divisible by 4, the rule is that you have to look at the last 2 digits and see if the last 2 digits are divisible by 4. So in this case, the last 2 digits are just this 0, 0, and this one actually is divisible by 4 because 0 divided by like anything is just 0. So that means that this is going to be divisible by 4. So we just say yes. And then for the next one, last 2 digits are just this 16. And is 16 divisible by 4?
Yes.
Awesome. So that means that this whole number is going to be divisible by 4. And I tried to make it kind of like, an ugly number that you would look at and say, there's no way that that is going to be divisible by 4. But the main idea is that, it doesn't really matter how it looks on the other side. Like you can look like something that would not be divisible by 4 at all. But the last 2 digits are the only thing you have to look at. And that can tell you if the whole thing is divisible by 4 or not. How about this last example? See, this one is something that does look like it would be divisible by 4. But when you just look at the 22, you see, is 22 divisible by 4?
No.
Exactly. So that's how you know that even if it looks like it might be divisible by 4, doesn't mean it necessarily is. You just have to look at those last 2. And also, just because it's even does not mean it's divisible by 4 either. But definitely, only even numbers can possibly be divisible by 4. Okay, next one. How can you tell if a number is divisible by 8? So this one, like I said, these guys come in pairs, and this one is a pair with the 8. The only thing is the 8 is not as nice. So in a lot of books that I've seen, usually the 8 is one of those where there's like no rule and they just tell you to divide. And the truth is there is kind of a rule, but it's so annoying that you might as well just divide. But nonetheless, there is a rule, and it is that just like with 4, how you have to look at the last 2 digits, this one you have to look at the last 3 digits and see if the last 3 digits are divisible by 8. So I have these 2 examples here, And the first number, if we look just at this part, and we're just looking at the last three digits, which basically means we have 72. Is 72 divisible by 8?
Uh, yes, it is, right?
Yes, it is, because 8 times 9 is 72. So then that means that this number is going to be divisible by 8. Now this situation is nice because I put a 0 right there, and so that means it's less than 100. You're really just looking at those last two numbers. But in a number like this, you can't really tell just like that. You would actually have to divide it out. Okay, so let's go ahead and divide here. We're going to divide the 992 by the 8 right here. And so we do 8 into 9, and that goes one time, and then you're going to have a remainder of 1. So I'm showing you guys also my little shorthand that I do for dividing here, which is basically instead of writing everything out down here, I just figure out what that remainder would be. So, 8 times 1 is 8. And then when you subtract it from 9, you get a 1. So I just put the 1 right there, like a 19. So now that's looking like 19 for the next number. And so how many times can 8 go into 19, Calculina?
2 times?
Yes, so I put the 2 up here, and 8 times 2 is 16. And when we take that away from the 19, what do we get?
3.
Awesome. So I write the little 3 over here, so it now looks like a 32, and I'm doing 8 into 32. How many times does 8 go into 32?
Uh, 3 times?
Nope, it's not 3, it's 4. 8 times 3 is 24, so 8 times 4 is 32.
Oh, okay, yeah.
Okay, cool. So I put the 4 here, and we know that that goes in evenly, and so that means this is going to be a yes. So basically my shorthand for dividing, and whenever I have to do this like quickly in my head, then yeah, I just use these little mini numbers right here, and I don't have to write out the whole thing. Sometimes I even do that just like looking at the number here. I can just do like, oh, 8's going to go one time into the 9, and then that's going to be a 19, and so on. So that's just the quick trick. But there's also another trick for dividing by 8, which is like you can just do half of the number. Usually that's kind of easy to do. And then do half of that again, and then half of that again. So you can also do that for 4, except you just do half twice. The next number we're looking at is how to tell if something is divisible by 6. This one, the way that you tell is if it is divisible by both 2 and by 3, then that means it is going to be divisible by 6. Okay, so let's try these examples here. The first one, is it divisible by 2? So there's 2 checkpoints. You're going to see, is it divisible by 2 and is it divisible by 3? Is it divisible by 2?
Yes.
Good. It is divisible by 2 because it's even. And is it divisible by 3?
So I do 8 plus 8 plus 2. And so that will give me 16 plus 2, which is 18. And 18, yes. So it is divisible by 3 as well.
Exactly. So 18 is divisible by 3, and so that means the whole number is divisible by 3. And so, yes, that means that this guy is going to be divisible by 6. Awesome. How about this one? Let's do the 2 and the 3. Is it divisible by 2?
Yes.
All right, cool. And then is it divisible by 3?
No.
No, it is not. So that means that this is not going to be divisible by 6. So that's how the 6 is done. And then the last one is 7. And I saved this one for last because the rule for 7 is that there is no rule. The only way to tell if something is divisible by 7 is that you literally have to divide. But let's look at these two. So out of these two examples, which of these do you think is going to be divisible by 7?
Um, the first one?
Yeah, see, that's what I would have guessed too, because it just looks like it might be divisible by 7, and the fact that this one's even kind of makes me feel like maybe not, but actually, I think it's the other way around. So this one is divisible by 7, this one is not. Let's go ahead and try and divide on the side and see what we get. So if we did, we'll do the shorthand division. Let's try this one first. So 7 and then 1, 3, 5, 7 right here. Okay, 7 into 13. Since it can't go into the 1 by itself, what's that going to be? How many times 7 go into 13?
One time.
Good. And then what would be the remainder from that?
Uh, what do you mean?
Well, like normally you would do 7 times 1 and you get 7, right? And then you'd subtract. What do you get when you subtract there?
Um, a 6?
Yes, exactly. So the way that I do this shorthand is that I'll write the 6 up here so that now it looks like a 65. Does that make sense?
Oh, okay, yeah.
Okay, so now if we're looking at 65, how many times can 7 go into 65?
Um, 7 can go into 65. Well, 7 times 9 is 63.
Yes, exactly. So it can go in 9 times. And then what would be the remainder when we subtract the 63?
Uh, that's going to be a 2.
Good. So we put the 2 right there, and now we're looking at a 27. How many times can 7 go into 27?
Uh, 3 times. And then you'll have a remainder of a 6.
Yes, exactly. So since we have a remainder, this is not going to be divisible by 7. And then let's just do the other one really quick as well and see how this goes. So 7 into 4,088. So how many times does 7 go into 40?
That would be, is it 6 times?
No, it's not 6 times because 6 times 7 is 42.
Oh, okay, then it's 5 times.
Yes, so I write the 5 right above the 0 like that, and then we have 7 times 5, which was 35, and you subtract that from 40. What does that give you?
That will be a 5.
Good, so now we're looking at 58. 7 goes into 58 how many times?
Uh, I know 7 times 7 is 49. So then 7 times 8 is 56.
Good, yes. So we put the 8 up here and we get the 56. And what do you get when you subtract that?
That is going to be 2.
Awesome. And then now we are just looking at 28. How many times can 7 go into 28?
That is, I'm like really bad with my 7 times tables. I don't remember them all the time like that.
I totally understand. These things, sometimes a lot of students will struggle with memorizing their times tables when they're younger. And then, as you get older, you don't need them so much anymore because you can use a calculator and all that kind of fun stuff. But it is good to be able to do math fast and just feel comfortable with it like that. So, sometimes if you go back and you try and relearn it when you're older, then it doesn't take that long to remember that stuff or to learn it at all compared to when you were a kid. But anyway, so back to this. You can think of well, you do know what 7 times 2 is, right?
Yeah, that's 14.
Okay, and then if you doubled 14, then wouldn't you get 28?
Yes.
So then those are tricks that you can use to do your times tables or try and remember this stuff if you do forget. So yes, in this case, we get a 4 right here, and then that is going to be 28. So there's no remainder, and so we have this one. It is divisible by 7. So yeah, the only way to tell if something is divisible by 7 is to actually go ahead and divide. We can't really tell just from looking at the numbers. So I have a couple of extra rules that we can look at here. The first one is rule for 11. So for 11, there is kind of a rule, right? Like I can ask you, like, is 77 divisible by 11? And you can tell right away, yes, it is. And that's because you know the times tables, like from 1 to 10 times 11. So those ones are kind of easy. But then when you get into 11 times like bigger numbers, let's say if I did 11 times, uh, even if I did 11 times 11, let's look at that one. The way that it works is you are going to do, so like let's say if I'm doing this 11 times this number right here, I take this number and I split it up so there's a 1 and 1, and then in between I have to add the two numbers on either side. So these guys, I add those up and then I will get a 2, and so that's what will go right in the middle, right there, and you would get a 121. So in the middle, you add those guys on the side. That's like a really quick way of multiplying. So I guess it's not really a divisibility rule. This is more like a quick rule for multiplying by 11 when you have numbers that are bigger than like 10 or the ones that you know already. So let's try another example. How about 11 times like 27? If we want to do 11 times 27, so you're going to take this 27 and you split it up like this, and then in the middle you're going to add the two numbers. So 7 plus 2, that's a 9, and so this number is basically 11 times 27. And then
Wait, I have a question. You just did 11 times 27, and when you added those, it became a 9 in between. But what if the number in between is bigger?
that is a really good question. So you mean like something like if I did, so since we did 11 times 27, what if we had done something like 11 times 47? Is that what you mean?
Yeah, I think so.
Okay, because then, yeah, here you would split the number. You get the 4 and the 7, right? And then when you add 4 and 7, what does that give you?
That's 11.
Yes, so 7 plus 4 is 11. And then it's not like you're going to put the 11 in between, right? So here's how you do that. You basically, it's like you put one here, and then the other one for the tens, you're going to add that to this guy. So really the answer should be 517. Does that make sense?
Oh, okay. Yeah,
Do you want to try one?
sure.
Okay, why don't you try 11 times 59?
Okay, so then you're going to write a 5 and then a 9, and in between you're going to have a blank spot. And then you're going to add 5 plus 9, which gives you 14.
Good.
And then you put a 1 in the middle.
Nope, that's where the 4 goes. The 4 goes here, the 1 goes up here, like you're carrying it over. And so what is the final answer going to be then?
Oh, then I add the 1 plus 5, so it's going to be 649.
Yes, exactly. Okay, so that's the trick for multiplying 11 times anything with 2 digits. Okay, then another rule is for how to tell if a number is divisible by 15. This one's kind of easy as well. You just have to see if it is divisible by 5 and by 3. So if a number is divisible by 5 and by 3, then that means it is divisible by 15. And then the rule for 25, this one's kind of easy. To tell if a number is divisible by 25, it has to end in 00 or 25 or 50 or 75. So it ends in these guys. Okay, and so those are all of the divisibility rules. They sound like it would be hard to memorize these, but trust me, it's actually not that bad. And you guys have some practice problems now that you can do for this in the exercises.